So we're finding the inverse for this one. So we'll start off the same way. Y equals 3 times x plus 6 squared minus 1. So we'll make this x equals, because g of x is really just y. And don't forget to actually make that a y. Okay, so we got to get rid of this 1 and we have to get rid of this 3 halves. So I'm going to add the 1 over. Make this x plus 1 equals 3 halves y plus 6 squared. So, same thing with this fraction. Since the denominator is 2, we're going to cancel that out first by multiplying both sides by 2. That will cancel. So, on the left, we have 2x plus 2 equals now 3 times y plus 6 squared. So we want to divide both sides by 3, because it's 3 times y plus 6 squared. So 2x plus 2 over 3 now equals y plus 6 squared. So how do we undo the squared power? We're going to take the square root. That undoes that and leaves you with just y plus 6. But here's the trick. If you have a fraction on that left-hand side, we need to rationalize the denominator, because at this point, if you guys were to write this as 2 separate radicals, it would be the square root of 2x plus 2 over the square root of 3. So we need to rationalize this, which isn't hard, before we get rid of that 6 on the right-hand side. So we have a square root of 1, 3. So this is like 3 to the first, right? So we just need to multiply and rationalize this left-hand side. So we're going to multiply both the numerator and the denominator by square root of 3. The bottom will now be rationalized. The top will become the square root of 6x plus 6. On the right, we still have y plus 6. So the last thing to do is just subtract that 6 over. And we can leave it as y, but we're going to write it as the inverse g negative 1 of x. So you guys have to be careful if you end up with a fraction to make sure we don't need to rationalize it. Like, say you would have had 4 on the bottom, then the square root of 4 would have just been 2, and you would not have needed to rationalize it. But in this instance, you do need to rationalize the denominator when you're finding the inverse. We can't have that radical in the denominator.